what if the universe has been pulling a fast one on us this whole time? Well, the James Webb Space Telescope just blew the lid off some serious cosmic secrets, and now space has a lot of explaining to do. Let's back up. For decades, scientists thought they had the universe pretty well figured out. Dark matter? Check. Dark energy? Check. The Big Bang's leftover glow? Sure, makes sense. But then came Webb, snapping ultra-clear deep space glamour shots, and suddenly, nothing is adding up. Galaxies are showing up in places they have no business being. Timelines are warping like they're in a sci-fi movie. The entire cosmic narrative we've been piecing together for generations, starting to look more like fan fiction than fact. As Andre Cuziano from the Lawrence Berkeley National Lab put it, we thought we were just taking notes. Turns out, the universe is freestyling. And it gets weirder. Buckle up, because even gravity, that dependable force we thought we knew so well, might be going rogue. Yep, gravity. The reason your coffee spills instead of floats and your feet don't drift off into the clouds apparently didn't get the memo about how it's supposed to work. Let's break it down. We all know gravity's deal. The closer you are to something massive, the stronger its pull. The sun tugs hard on Mercury, like a clingy ex who just won't let go. But Pluto? Way out in the solar system's icy burbs, the sun barely keeps a grip, more like a distant wave than a full-on hug. So far, so good, right? That's the classic rule. Distance weakens gravity. But then, cue the plot twist. Back in the 1970s, astronomer Vera Rubin was studying how stars moved inside galaxies, and what she saw made zero sense. It was like watching a merry-go-round where the horses on the outer edge spin just as fast as the ones near the middle. According to everything we thought we knew, those outer stars should have been flung into space like galactic frisbees. But they weren't. They held tight, orbiting steadily, as if something invisible was keeping them in line. That something became one of the biggest mysteries in modern science: dark matter. Whatever it is, we still can't see it. We can't touch it, but it seems to be holding galaxies together, like cosmic duct tape. And now, with the Webb telescope showing us things we've never seen before, even that theory might need a rewrite. So what the heck is going on in the multiverse? Are we missing a chapter, or is the universe just making it up as it goes? Stay tuned, because we're about to dive into the cosmic chaos, laugh through the confusion, and ask the one question everyone's thinking. Did the universe just ghost science? There's something out there in the universe, silent, invisible, and totally unbothered by our best telescopes. So of course, scientists gave it a name straight out of a sci-fi movie: dark matter. It doesn't shine, it doesn't reflect light, and nope, it doesn't pay rent. But somehow it might be the glue keeping the entire universe from falling apart, kind of like cosmic duct tape on a shaky IKEA shelf. Yeah, the universe has secrets, and this one, it's possibly the biggest of them all. So, here's the deal. Dark matter is like that weird neighbor who never opens their blinds. No one really knows what it is, what it's made of, or what it's even doing. But we're pretty sure it's been quietly running the show behind the scenes for billions of years. According to the leading theories, right after the Big Bang, when regular matter first popped into existence, dark matter jumped in like a cosmic foreman, using its gravity to pull things together. Galaxies, stars, the massive web of stuff we call the universe, it was all built with dark matter playing the scaffolding. Even the tiny temperature bumps in the cosmic microwave background, the universe's baby photo, seem to show dark matter flexing its early influence. For decades, this invisible ingredient made perfect sense. That is, until now. Because the James Webb Space Telescope, it's turning that theory inside out. Webb has been spotting galaxies way farther and way earlier than we ever thought possible. We're not just talking minor tweaks to our models here. We're talking total rewrite. Imagine spotting a galaxy that formed just 200 million years after the Big Bang. The universe was practically a toddler, still figuring out how to exist. One confirmed galaxy, nicknamed MOMZ14, adorable, right? Was already up and running when the universe was only 280 million years old. And it's not alone. There are potential galaxies even older, still waiting to be confirmed. That's like walking into a daycare and finding a full-grown adult running a business in the corner. It just shouldn't be there. But here's the real twist. These early galaxies, they're not small or chaotic like we'd expect from baby universes. They're huge, they're organized. Some are even full of old stars. One massive show-off, JO107A, is about 10 times bigger than the Milky Way, and it was already thriving when the universe was still wiping drool off its chin. Which leaves us with a big cosmic question. If dark matter is supposed to be the slow and steady builder of galaxies, how did these massive, mature galaxies get here so fast? Suddenly, dark matter's reputation is looking a little shaky. Have we misunderstood what it actually is? Or, brace yourself, is it possible dark matter doesn't even exist the way we think it does? These are the kinds of questions that keep astrophysicists up at night, staring into the dark, asking themselves if everything they thought they knew was wrong.
For decades, dark matter has been the universe's quiet MVP. The behind-the-scenes force shaping galaxies from infancy to grandeur. But now, Webb is peeling back the curtain and showing us something unexpected. Galaxies that don't follow the script. Galaxies that break the timeline. So here we are, stuck with two not-so-comfy options. One, we're missing something massive about how dark matter behaves. Or, dark matter isn't what we thought it was at all. And it's been playing a completely different game. Either way, those ancient galaxies, yeah, they're just the opening act. The James Webb Space Telescope isn't just giving us jaw-dropping snapshots of distant galaxies. It's pulling back the curtain on the universe's biggest secrets. And now, it's exposing some seriously strange behavior happening on epic scales. We're talking about the largest structures in the cosmos. Galaxy clusters, superclusters, and these massive thread-like filaments that stretch across the universe like a cosmic spiderweb. To us, the Milky Way is huge, but in this context, it's barely a speck. And just when we thought dark matter might be the mysterious glue holding all this together, it's back to raising more questions than answers. Now, enter the latest plot twist. Something scientists call S8 tension. Basically the universe's version of a software glitch in reality itself. So what is S8? Think of it as a number that describes how clumpy matter is across the universe. It's kind of like a cosmic report card on how matter has spread out and formed all the galaxies and clusters we see today. In theory, it should be simple. When scientists look back to the early universe using the cosmic microwave background, the faint afterglow from the Big Bang, they get one value for S8 that fits perfectly with our current models. Neat, predictable, science-y. But here's the kicker. When they look at the present-day universe, using actual galaxy surveys and telescope data, S8 turns out to be lower. Not just a tiny bit either, significantly. That's like asking someone for directions and getting two completely different maps, both drawn by professionals. One from the past, one from the present. And they don't match up. So what gives? Either our understanding of the early universe has some serious blind spots, or the cosmos is messing with us. Whatever the case, this S8 tension is one of the biggest modern mysteries in cosmology. And thanks to Webb's high-def eye on the universe, it's getting harder to sweep under the rug.
Now, you might be thinking, okay, so the numbers don't match. Big deal. But in astrophysics, even a small mismatch can mean the entire universe has been fibbing. This discrepancy is consistent, statistically solid, and way too stubborn to blame on a math error. And guess what? It's not just dark matter acting sketchy. Dark energy, the mysterious force we thought was peacefully inflating the universe like a gentle balloon, is now under suspicion too. Here's the weird part. When scientists measure how fast the universe is expanding, the Hubble constant, they get one number from the ancient light of the Big Bang, and a totally different number when they measure closer using exploding stars called supernovae. This disagreement has a name, Hubble tension. And no, it's not just some harmless family squabble, it's more like a full-on cosmological identity crisis. But wait, it gets even messier. Some scientists now think dark energy might not be constant after all. Yep, the one thing we thought was stable might actually be evolving, changing over time like a grumpy teenager going through phases. That shakes the very foundation of how we understand the universe's expansion. It's like building a skyscraper, then realizing halfway up that gravity is changing and nobody told you. And just when you think it couldn't get any weirder, there's this. Remember the CMB, the cosmic microwave background, the so-called holy grail of cosmological evidence, the baby picture of the universe? Yeah, that too might not be exactly what we thought it was. So here we are. Our best models are cracking, our constants aren't constant, and the universe is behaving like it's rewriting its own instruction manual while we're still trying to read the old one. Strap in, because this cosmic roller coaster, it's not slowing down anytime soon. A brand new study just dropped, and it's sending shockwaves through the astrophysics world. Get this, what if the cosmic microwave background, the CMB, that faint glow we've always called the universe's baby picture, isn't what we thought it was? What if it's not the leftover echo from the Big Bang, but just the combined glow of a bunch of early galaxies all jammed together like sardines?
Picture it. The first galaxies bursting with young hot stars, blazing with intense radiation. Over billions of years, that radiation stretches out, thanks to the expanding universe, until it lands smack in the microwave range. And that, say these researchers, could mimic the CMB almost perfectly. According to this new study, these early galaxies could account for about 1.4% of the CMB's total energy. And yeah, that might sound tiny, barely a drop in the cosmic bucket, but in physics, that's huge. It's enough to throw off measurements, to rattle assumptions, to make scientists pause mid-equation and go, wait, what? And here's the twist. That 1.4% is just the conservative estimate. Add more ancient galaxies to the mix, and that number could climb. If these galaxies turn out to be responsible for a major chunk or even all of the radiation we thought came from the Big Bang, then we're looking at a major rewrite. We're not talking footnotes in a textbook. We're talking full-on tear out the chapter and start over. Everything, from the age of the universe to how galaxies formed to the very rules we thought governed the early cosmos, is now under the microscope. Dark matter? Suddenly, not so certain. Dark energy? Feeling shaky. And the Big Bang itself might be losing its cosmic crown. Even the beloved CMB, the baby picture we've obsessed over for decades, might have been photobombed by ancient galaxies we didn't account for. And just when things couldn't get any weirder, here comes the James Webb Space Telescope again, flipping the script. Webb just spotted 30,000 galaxies. That's a lot. But here's the strange part. Most of them? They're all spinning in the same direction. Yeah, like the universe coordinated a cosmic dance routine and no one gave us the rehearsal schedule. This is a big deal because according to the classic Big Bang model, the early universe should have been a chaotic mess. Galaxies should be spinning randomly, like figure skaters after too much coffee. But nope, these galaxies are synchronized, aligned, organized. And here's the kicker. The deeper into the past Webb looked, the stronger the trend got. The older the galaxy, the more likely it was spinning in sync with the rest. So now scientists are asking a wild question. Did the universe start with a spin? We're not just poking holes in theories. We're unraveling the whole sweater.
One discovery at a time. The universe is proving to be weirder, wilder, and way less predictable than we ever imagined. And this cosmic mystery, it's just getting started. The deeper we look into the universe's past, the more it feels like maybe it wasn't random at all. Maybe the cosmos had a plan, and it's been hiding it from us this whole time. And that plan, it doesn't fit our current rulebook. Dr. Lior Shamir and his research team started digging into the mystery of galactic spin, using redshift data to trace how galaxies have rotated across cosmic time. What they found? A pattern. A real, measurable pattern. And here's the kicker. It shouldn't exist. Not according to our best models. It's not just a fluke or a quirky set of numbers. It's the kind of data that makes scientists sit back, stare at the screen, and go, wait, what? If it holds up, it means something big. Like rewrite the laws of physics big. Our current theories can't explain it, not even close. But hang on, it gets even weirder. Just when we thought we'd reached peak cosmic weirdness, another study dropped, this time in Physical Review D, and it brought a total mind bender. Ready for it? What if our entire universe is inside a black hole? Yeah, you heard that right. According to a team at the University of Portsmouth, the Big Bang might not have been the fiery explosion from a single point that we've been picturing since grade school. Instead, it might have been the rebound from a collapsing star, a black hole that didn't just collapse into a singularity, but bounced back and launched an entirely new universe on the other side. That new universe could be ours. Professor Enrique Gastañaga, one of the researchers behind this idea, puts it like this. Gravity can crush matter down to mind-blowing densities, but it doesn't have to end in a dead-end singularity. Instead, the crushed matter might hit a kind of cosmic trampoline and bounce outward, creating an expanding universe in the process. And what about the edge of our universe? That would be the event horizon of the original black hole, the outer boundary of space and time itself, the literal point of no return. So now, we're not just asking how the universe started, we're asking where and from what, and maybe, just maybe, inside what. Buckle up, because the universe might be a lot stranger and a lot more connected to black holes than we ever imagined. So, what if the reason we can't see anything outside the universe is because there is no outside? Picture it. We're sealed in tight, like raisins, baked into a cosmic pudding, with gravity as the flavor holding it all together. From galaxies moving in unison to wild theories about black hole baby universes, one thing's becoming crystal clear. The James Webb Space Telescope isn't just out there snapping jaw-dropping photos. It's flipping the entire script on what we thought we knew about the cosmos. And if the universe is playing by a rulebook we haven't even discovered yet, we've got a whole lot of cosmic homework ahead.
Now buckle up, because here comes a theory that'll twist your brain like spaghetti floating in zero gravity. The black hole universe theory. This bold idea says, nope, the universe didn't just pop into existence from nothing like some magician's rabbit trick. Instead, it may be part of a much bigger cycle, a grand loop where old collapsing universes don't end, they reboot. Every black hole? It might be the seed of a brand new universe. Collapse, bounce, begin again, forever. Sound wild? Well, it's not just science fiction. This theory echoes ideas from none other than Nobel Prize-winning physicist Sir Roger Penrose. He calls his version conformal cyclic cosmology, or CCC for short, in case you're into snack-sized names for mind-melting theories. According to Penrose, the Big Bang wasn't the absolute beginning. It was just the opening act of the next universe. In his view, each universe, what he calls an eon, doesn't go out with a bang, but more like a slow fade. The stars burn out, the black holes evaporate, space stretches until it's flat and cold, and then, boom, a new one begins. So yeah, we could just be part of one page in a never-ending cosmic story. And before us, who knows how many other universes lived and died? Some of them might have had better music, cooler aliens, or at least a decent universal Wi-Fi signal. Right now, the Webb telescope is looking deeper into space and further back in time than we've ever gone before. It's not just helping us understand how our universe began, it's making us ask, did it ever really begin? So, get your popcorn ready because this show, far from over. Webb is just getting started, and the next chapter might be the biggest twist yet. If Einstein were here, he'd probably be pacing around going, "Did the universe just throw me a curveball?" If the Webb telescope's latest discoveries have you saying, "Wait, what?" Then hey, you're exactly where you need to be. Smash that subscribe button before the universe unravels even more.